We've mapped billions of galaxies. We've seen stars being born and dying in distant nebulae. We've even captured images of black holes. But every now and then, astronomers stumble upon something that defies logic, breaks known physics, or simply has no explanation. Tabby's star. Let's start with a star that refuses to behave like any other. KIC 8462852, better known as Tabby's star. Located about 1,500 light-years away, this F-type main sequence star shows bizarre fluctuations in brightness. Sometimes it dims by up to 22%, far more than what planets could cause. Some speculated alien megastructures, a Dyson sphere built by an advanced civilization. Others believed it was just dust clouds or comet swarms. But nothing fits perfectly. Even today, we don't know exactly what causes these dips. It remains one of the biggest cosmic mysteries. The wow signal, a message from the unknown. It was just another night at the observatory, until it wasn't. On August 15, 1977, astronomer Jerry Amon was reviewing data from a radio telescope at Ohio State University's Big Ear Observatory, scanning the skies for unusual signals. Then he saw it. A powerful, narrow-band radio signal lasting exactly 72 seconds, long enough to be detected by the telescope as it swept across the sky. It was so intense and unexpected that Amon circled the numbers on the computer printout and wrote in red ink, "Wow." That single word gave this mysterious signal its name, the wow signal, and turned it into one of the most enduring mysteries in space science. What was the wow signal? Signal was a strong, narrow-band radio wave detected at a frequency of 1420 megahertz. A frequency known as the hydrogen line, which is considered a likely channel for interstellar communication due to its natural occurrence in space and low background noise. The signal lasted exactly 72 seconds. The maximum time the telescope could observe a single point in the sky came from the direction of the constellation Sagittarius, was 30 times stronger than the usual background noise, showed no modulation, no sign of encoded information, but appeared deliberately focused, and then it vanished. Despite decades of follow-up observations with more advanced equipment, the signal was never detected again. Why is it so mysterious? What makes the wow signal truly puzzling is how it defies easy explanation. Let's break down the possibilities. 1. Was it extraterrestrial? This is the most exciting theory, and the one that captured public imagination, because the signal was narrowband, like artificial transmissions, strong, indicating high power or proximity, unmodulated, possibly a beacon, never repeated, making it unlikely to be interference. It fits the profile of what scientists would expect from an alien transmission. If not a message, then perhaps a beacon sent out by a distant civilization. But without a repeat, we have no way to confirm. 2. Could it be natural? Some researchers suggest the signal may have come from a natural astrophysical source, such as a passing comet emitting radio waves, an unknown type of pulsar or quasar, a burst of radiation from a magnetar or black hole. However, none of these explanations fully match the characteristics of the wow signal. 3. Was it just a glitch? There's always the possibility that the signal was caused by terrestrial interference, for example, satellite, aircraft, ground transmitter, equipment malfunction or reflection, a rare atmospheric event. But again, nothing has been found to explain the signal conclusively. Where did it come from? The signal came from a patch of sky near the constellation Sagittarius, close to the star group called the Chi Sagittarii star system. about 142 light-years away. If the signal was coming from that distance, it would have needed to be extremely powerful, like a TV station signal, but coming from deep space. No stars or known exoplanets are located precisely in that area, making it even harder to trace the origin. The legacy of the WOW signal. The WOW signal remains the most compelling candidate for an extraterrestrial radio transmission ever recorded. It showed us that we can detect strange signals from space. Some signals might come from sources we don't yet understand. And sometimes, the universe sends us messages we're not ready to interpret. Even today, astronomers continue to search for similar signals using instruments like the Allen Telescope Array, the Square Kilometer Array, and SETI programs around the world. Dragonfly 44, the galaxy that's almost entirely invisible. At first glance, Dragonfly 44 looks like a normal galaxy, a faint, diffuse smudge of light floating in the vast darkness of space. But what lies beneath its dim glow is truly astonishing. This galaxy has about the same mass as our own Milky Way, yet it emits barely any visible light. Why? Because 99.99% of its mass is made up of dark matter, making it one of the most extreme examples of a dark galaxy ever discovered. In fact, Dragonfly 44 challenges everything we thought we knew about galaxies and how they hold together. What is Dragonfly 44? Discovered in 2015 by a team of astronomers using the Dragonfly Telephoto Array, Dragonfly 44 is an ultra-diffuse galaxy, UDG, a type of galaxy that's large in size but extremely low in brightness. It resides in the Coma Cluster, a massive collection of galaxies located about 300 million light-years away from Earth. Despite being roughly the same size as the Milky Way, Dragonfly 44 contains very few stars. So few, in fact, that if you stood on a planet inside it, the night sky would look almost empty compared to our own galaxy. But here's the twist. Even though it looks weak and fragile, Dragonfly 44 has the same gravitational strength as the Milky Way, which means something invisible must be holding it together. Why is it so mysterious? To understand why Dragonfly 44 is such a puzzle, let's take a step back. In most galaxies, the number of stars and gas clouds gives scientists a clue about how much mass the galaxy should have. By measuring how fast stars move within a galaxy, researchers can estimate its total mass, including the invisible part. And with Dragonfly 44, the numbers didn't add up. The stars were moving far too fast for the amount of visible matter present. That could only mean one thing. There was a massive amount of unseen mass, dark matter, providing the extra gravity needed to keep the galaxy intact. In fact, calculations showed that over 99% of Dragonfly 44's mass is dark matter, making it one of the most dark matter-dominated galaxies ever found. What does this tell us about galaxies? Dragonfly 44 forces us to rethink what makes a galaxy a galaxy. For years, scientists believed that galaxies formed around clumps of dark matter, which acted like scaffolding, pulling gas and dust into them, eventually forming stars. But Dragonfly 44 shows that galaxies can exist with almost no stars at all, held together purely by dark matter. So what does this mean? Did Dragonfly 44 once have stars and somehow lost them? Or did it form under unusual conditions where star formation never really took off? Could there be hundreds or thousands more galaxies like this, hiding in plain sight? These are the questions that make Dragonfly 44 so fascinating. How is it studied? To study Dragonfly 44, astronomers use some of the world's most powerful telescopes, including the Gemini Observatory and the W.M. Keck Observatory. By tracking the movement of stars inside the galaxy, scientists were able to calculate its total mass and realized that visible matter alone couldn't explain its structure. This led to the conclusion that dark matter must be the dominant force keeping the galaxy together. What makes Dragonfly 44 even more intriguing is that it behaves like a normal galaxy. It has globular clusters orbiting it, just like the Milky Way does. But unlike most galaxies, those clusters are orbiting something we can't see. Ozzy's object, the cosmic mystery between a black hole and a neutron star. In the vast emptiness of space, astronomers have discovered something that shouldn't exist, or at least shouldn't exist according to our current understanding of astrophysics. This object is known as Ozzy's object, a strange and compact celestial body with a mass of about 3 times that of our Sun. That might not sound impressive compared to supermassive black holes or exploding stars, but this number has scientists scratching their heads. Because 3 solar masses places Ozzy's object in what's called the mass gap, a range where neither neutron stars nor black holes should be found. And that makes it one of the most fascinating discoveries in modern astronomy. Ozzy's object was discovered using a technique called gravitational lensing, a phenomenon predicted by Einstein's theory of general relativity, where massive objects bend light like a cosmic magnifying glass. By observing how background light from distant stars bends around unseen objects, scientists can detect otherwise invisible entities in space. What they found was unusual. An object roughly 3 times the mass of the Sun, floating silently in the void. It doesn't emit light. It doesn't pulse like a neutron star. It simply exists, quietly warping space-time around it. Why does this confuse scientists? For decades, scientists believed that stellar mass black holes formed when massive stars collapsed under their own gravity, and those typically weighed at least 5 times the mass of the Sun. Neutron stars, the ultra-dense remnants of supernova explosions, are usually no heavier than 2.2 solar masses. So where does Ozzy's object fit in? It's too heavy to be a neutron star, and too light to be a typical black hole. This puts it right in the middle of what's known as the stellar mass gap, a theoretical dead zone where such objects shouldn't exist. Which raises a big question. Is Ozzy's object a new kind of black hole? A strange type of neutron star? Or something entirely different? Could it be a primordial black hole? One of the most exciting theories is that Ozzy's object may be a primordial black hole, a hypothetical type of black hole that didn't form from dying stars, but instead emerged directly from the extreme densities of the early universe. Unlike stellar black holes, which form from supernovae, primordial black holes would have formed just moments after the Big Bang. When the universe was still a hot, dense soup of energy and matter, they could range in size from microscopic to several solar masses. And if they exist, they might help solve one of the greatest mysteries in cosmology. What is dark matter made of? Ozzy's object and the dark matter puzzle. Dark matter makes up about 85% of all mass in the universe, yet we've never directly observed it. We only know it exists because of its gravitational effects on galaxies and stars. Some scientists believe that primordial black holes, like Ozzy's object, could make up a portion of this elusive dark matter. If true, then Ozzy's object wouldn't just be an oddity. It would be a missing piece in the puzzle of the universe's hidden mass. Of course, this idea is still speculative, but every time we find something that defies expectations, we open a new door to understanding the cosmos. How was it detected? Ozzy's object was detected thanks to gravitational microlensing, a method that allows scientists to spot invisible or dim objects by watching how they distort the light of stars behind them. This technique is especially useful for detecting isolated dark objects that don't interact with their surroundings in obvious ways. The data suggests that Ozzy's object is not part of any visible binary system, and it emits no detectable radiation, making it even more mysterious. NGC 1052 DF2, the galaxy that shouldn't exist. Dark matter is one of the greatest mysteries in modern astrophysics. It doesn't emit or reflect light, but scientists believe it makes up about 85% of all mass in the universe. It acts like cosmic glue, the invisible force that holds galaxies together. Without dark matter, galaxies shouldn't exist. But then came NGC 1052 DF2, a ghostly faint galaxy located about 65 million light-years away in the constellation Cetus. And it changed everything. Because this galaxy appears to contain almost no dark matter at all. NGC 1052 DF2, often shortened to just DF2, is an ultra-diffuse galaxy, meaning it's large and spread out, but with very few stars compared to galaxies like our own Milky Way. It was first discovered using the Dragonfly telephoto array, a special telescope designed to detect faint, low-surface brightness objects. At first glance, DF2 looked unremarkable, but what came next shocked the scientific community. Astronomers measured the motion of star clusters inside DF2 and found something impossible. The stars were moving far too slowly to suggest the presence of dark matter. In most galaxies, the visible matter alone can't explain how fast the stars move, which is why we infer the existence of dark matter. But in DF2, the numbers added up without any need for dark matter at all. Why is this discovery so important? This discovery challenged everything we thought we knew about galaxies. For decades, scientists believed that dark matter played a central role in galaxy formation. The idea was simple. Dark matter clumps together early in the universe, creating gravitational scaffolds that pull gas and dust into them, eventually forming stars and galaxies. But if DF2 formed without dark matter, then what does that say about our models? Is dark matter truly universal, as we assumed? Or are there galaxies that form through completely different processes? DF2 forced scientists to rethink long-held assumptions and open the door to new possibilities. How was it studied? To study DF2, astronomers used powerful telescopes like the Hubble Space Telescope and the Keck Observatory to track the motion of 10 bright star clusters within the galaxy. They calculated how fast these clusters moved, and from that, estimated the total mass of the galaxy. What they found was astonishing. The mass of DF2 could be fully explained by the visible stars and gas alone. There was no room left for dark matter. This made DF2 not just unusual, it made it unique. Could DF2 be a sign of new physics? Some scientists suggested that DF2 might be evidence that our understanding of gravity itself needs to change. One alternative theory is modified Newtonian dynamics, MOND, a model that suggests gravity behaves differently on large scales, eliminating the need for dark matter altogether. DF2 became a key test case for these ideas, because if MOND worked, it should still predict the same motions of stars in DF2, even without dark matter. Is DF2 alone? Surprisingly, DF2 is not the only galaxy of its kind. Not long after its discovery, astronomers found another similar galaxy, NGC 1052 DF4, also appearing to lack dark matter. This suggested that DF2 wasn't a one-off anomaly, but part of a new class of galaxies that defy standard cosmological models. Scientists are now searching for more such galaxies to understand whether they formed in rare conditions, lost their dark matter over time due to interactions with other galaxies, or reveal a fundamental flaw in our current theories. The Great Wall, the largest structure in the universe. When you think of massive cosmic structures, galaxies or even galaxy clusters might come to mind. But what if we told you that there's a structure so vast, it stretches across over 1.4 billion light-years? This is the Great Wall, also known as the CFA2 Great Wall, an enormous filament of galaxies stretching across space like a cosmic bridge between the stars. It's not just big, it's too big, and its very existence challenges our understanding of how the universe works. What is the Great Wall? The Great Wall is one of the largest known structures in the observable universe. Discovered in 1989 by a team of astronomers led by Margaret Geller and John Huchra at the Harvard-Smithsonian Center for Astrophysics, this colossal structure is a filament of galaxies, a long, dense chain formed by the gravitational pull of countless galaxies. Imagine thousands of galaxies, each containing billions of stars, linked together in a giant cosmic web. That's what the Great Wall looks like. A wall-like structure of matter spanning more than 1.4 billion light-years across. To put that into perspective, light from one end would take over 1 billion years to reach the other. It dwarfs entire superclusters of galaxies. It's more than 100 times bigger than the distance between the Milky Way and Andromeda. And yet, despite its size, it's almost invisible to the naked eye, only detectable through deep space surveys and redshift mapping. Why does it challenge our understanding? Our current cosmological models, based on the Big Bang Theory and the role of gravity and dark matter, predict that large-scale structures form slowly over time. Galaxies begin to clump together under gravity, eventually forming clusters and superclusters. But here's the problem. According to these models, structures larger than about 300 to 500 million light-years shouldn't exist, because there hasn't been enough time since the Big Bang for gravity to pull such massive amounts of matter together. So when scientists found something 3 times larger, they were stunned. How did the Great Wall form? Why did it form? And most importantly, does it mean our theories are incomplete? The Great Wall was discovered during the CFA Redshift Survey, a project aimed at mapping the 3-dimensional distribution of galaxies in our universe. Using redshift measurements, researchers could determine how far away galaxies were and how they were distributed. What they saw was shocking. Instead of a relatively uniform spread of galaxies, they found a massive concentration, a wall of galaxies, extending across an incredible stretch of space. This discovery changed how we view the large-scale structure of the cosmos, the cosmic web and filaments. The Great Wall is part of what's known as the cosmic web, a vast network of filaments and voids where galaxies tend to cluster along thin threads of dark matter and gas. Most filaments are smaller and scattered throughout the universe, but the Great Wall is unique in both scale and density. It defies expectations and raises questions about whether there are even bigger structures hiding in the darkness beyond our current observations. The cold spot. Now imagine a place in the universe where something feels off. A region colder than it should be, stretching across nearly 1.8 billion light-years. This is the cold spot, a mysterious patch in the cosmic microwave background radiation, the afterglow of the Big Bang. It's not just cold, it's too cold. According to our models, such a large cold area shouldn't exist. One theory? This might be a collision point between our universe and another. Evidence of the multiverse, the cold spot, a cosmic mystery. Imagine a place in the universe where something just doesn't seem right. A region colder than it should be, stretching across nearly 1.8 billion light-years. It stands out like a glitch in the grand design of the cosmos. This is the cold spot, one of the most puzzling anomalies ever discovered in space. The cold spot is a mysterious region in the sky, detected in the cosmic microwave background radiation, the faint afterglow of the Big Bang. This radiation fills the entire universe and gives us a snapshot of what the cosmos looked like over 13 billion years ago. Normally, temperature fluctuations in this radiation are tiny, just fractions of a degree. But the cold spot is different. It's about 0.0015 degrees Celsius colder than its surroundings. Not much, but in cosmic terms, it's significantly colder than it should be. What makes it even more strange? Its size. The cold spot spans roughly 1.8 billion light-years, making it one of the largest structures ever observed in the known universe. Why does it confuse scientists? According to our best models of cosmology, such a large and cold region simply shouldn't exist. The early universe was filled with small, random fluctuations, but nothing on this scale. Some scientists suggest that the cold spot could be caused by a giant cosmic void, a region with far less matter than average. Voids can cause slight cooling effects due to how light travels through them. But for the cold spot, the void would have to be unusually large and empty, which is hard to explain with current theories. In short, the cold spot shouldn't be there. And yet, it is. Theories and hypotheses. Scientists have proposed several explanations, but none fully convince everyone. 1. A giant cosmic void. The most straightforward theory says the cold spot is caused by an enormous underdense region, a cosmic desert, where galaxies, stars, and even dark matter are extremely sparse. But again, such a massive void is unlikely based on our understanding of structure formation in the universe. 2. Evidence of the multiverse. One of the most fascinating ideas is that the cold spot might be the imprint of a collision between our universe and another universe, a sign of the multiverse. If our universe is just one of many, like bubbles in an infinite cosmic foam, then it's possible we've brushed against another bubble long ago. That interaction could have left a mark, and the cold spot might be it. New physics at play. Another possibility is that the cold spot hints at unknown physics, new laws of nature that we haven't discovered yet. It might be linked to dark energy, quantum gravity, or other exotic phenomena beyond the standard model of cosmology. How was it discovered? The cold spot was first identified using data from NASA's Wilkinson Microwave Anisotropy Probe, WMAP. Later, it was confirmed by the European Space Agency's Planck satellite, which mapped the cosmic microwave background in unprecedented detail. These instruments allowed scientists to see the subtle temperature variations across the ancient sky and spot the anomaly that became known as the cold spot. Not directly. You won't find it glowing in your telescope. It exists only in the data, in the patterns of the microwave background radiation that surrounds us like a cosmic echo. But thanks to these invisible signals, we get glimpses into the deep mysteries of the universe. What's next? Research continues. Astronomers are using powerful radio telescopes and advanced simulations to study this region in greater depth. Whether the cold spot reveals a flaw in our models, a window into another universe, or something we haven't even imagined yet, one thing is certain. It reminds us that the universe still holds secrets we're only beginning to understand. Thank you for watching. We hope you enjoyed today's video. If you did, don't forget to hit that like button and subscribe to our channel for more exciting content. Your support means the world to us. We can't wait to see you back here for our next adventure. If you have any feedback or ideas for future videos, drop them in the comments below. Until next time, take care and stay awesome. See you soon.